welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, working on that Unit 8, Lesson number 5 now, and it says for that warm-up, it says true or false squared. So we're talking about this. We're saying, well, what's the difference between squaring a number and taking the square root? So we're saying, wait, we're saying square root. We're talking about square root. We're saying like a square root of x, like that. When we're talking about squaring, we're saying about squaring a value, so it'd be x or whatever number it is squared. Just make sure you're seeing the difference between those two. All right, so it says decide if each of those statements is true or false. And what I want you to do is to open up that Desmos calculator for yourself, make sure you can see how this works. And so what I can do is I can type it in exactly as it looks. Again, so for that first one, I can use those parentheses. So I'm going to say, if I have, actually make that a little bit larger on here. So let's do it like this, and oh, you guys can see the keyboard. So again, I want to use that square root button, so that way you can make sure you're using it correctly. But I have parentheses, square root of 5, and then I have, can use that arrow key and say exponent squared. So now we're saying, okay, well, that first one's going to be true. Like this, I can say this is true. However, like if I look at the second one, I can say I have square root of 9 squared. It should be equal to 9, which it is not. So we're going to say for that one, it's going to be false. So make sure you're seeing those differences between when you're squaring something and when you're taking the square root. So if you keep going, what about, let's say, looking at that right side, I have square root of 7 squared. You can notice how I type it in exactly as it looks. So that's going to be equal to 7, so that one's true. However, I have, if I have parentheses, square root of 10 squared, it's going to be equal to 10, so that one's false. And then the last one is going to be square root of 16 squared, or just sorry, square root of 16, that equals 4, which is the same as 2 squared. So just make sure I can see how each of those works. So we're going to say this is true, this one's true, and that second to last one is false. Again, make sure you're asking questions if you need to know how to use Desmos. All right, so now in the next part, we're talking about square root values. It says, what two whole numbers does each square root lie between? So make sure you can kind of explain your reasoning for this. So try this without, so this one, no calculator. So try no calculator. And what I want you to do is this. I can kind of figure out and use some numbers that I know. So what that means is use perfect squares. That just means, for example, if I could say since 2 squared equals 4 and 3 squared equals 9, I know that the square root of 7 is between I would say 2 and 3. And if I'm looking at that, I know that the value inside of that radical symbol, I'm talking about that value inside of the radical symbol, well, I know that 7 is in between 4 and 9, so that means when I take the square root, when I take that square root, it's going to be in between 2 and 3. And usually those numbers are going to be back to back or consecutive. So let me actually write that on the side here. Let me say this at the bottom. 2 and 3 are consecutive numbers. That just means back to back. Another way to think about it for that word consecutive, you can think of like consecutive days of the week would be Monday and Tuesday. So what I'm looking for is those consecutive numbers, those two whole numbers that those values go between. So same kind of idea. I could say since let's say 4 squared equals 16 and 5 squared equals 25, I know that the square root of 23, which is in between those two numbers, I know the square root is between 4 and 5. So try this one out. So let me say these. So pause and complete. Pause and complete the square root of 50 and the square root of 98. Again, use those perfect squares for yourself. So same setup, say since two numbers squared, and then you could say the square root will be in between those two bases. All right, so now same kind of idea. However, we're saying we're now taking the square root of this number. So it says the numbers x, y, and z are positive. So that means to the right of 0. We know that x is going to be the square root of 3. So I can say x equals the square root of 3. I can say y equals the square root of 16, which is 4. And I could say z is going to be equal to the square root of 30. So even though I don't know those exact values, I can find square root of 16 because that's a perfect square. And what you can do is you can kind of build this number line so that way it's a little bit easier to see. So when I write this number line, I can say, hey, this is the same thing as the negative square root of 9. This is the negative square root of 4. Negative square root of 1, square root of 0, square root of 1, square root of 4. So I'm just kind of rewriting these values so that way it's a little bit easier to see. So it's square root of 9, square root of 16, square root of 25, 36, 49, 64, 64. I don't know why my 4s always mess up. And lastly, for 9, that's the square root of 81. And so that way, when I'm looking at these values, I can kind of just look at, hey, I know that the square root of 3 goes in between 1 and 2, because if I'm looking at the value inside the radical symbol, it's going to be in between 1 and 4. So I can say, real simple, I'm going to say, well, I know also too it's going to be closer to 4, so I'm going to say put that point on the number line, draw an arrow towards it, and say square root of 3. Or sorry, let me just say x. I can just say x. That way it's a little bit easier. So that's going to be x. We already have y on there, so I can put that point on the number line and label that as y, because that's directly on 4, so that's equal to 4. And then I can say, what about z? Well, z is going to be in between 5 and 6, because 30 is in between 25 and 36. So I can say this is going to be where z is at. And then so we did part 1, and then for that part 2, it says plot that negative square root of 2. So I have to now move to the left. I'm going to say, well, square root of 2 is going to be in between, or negative square root of 2 is going to be in between negative 1 and negative 2. So I'm going to place that kind of like right here and say It's going to be negative square root of 2. So plot all 4 of those values on the number line. Notice how they are in between some values. However, on that value for y is directly on 4 since it is equal to exactly 4. So again, feel free to pause, rerun, replay as needed. So now on the back, talking about that lesson 5 practice, we're saying for the first part, it says explain how you know that the square root of 37 is just a little bit more than 6. So I can say something like this. Let me write it like this. I can say since the square root of 36 is exactly 6, that means that then the square root of 37, since 37 is a little more than 36, that means the square root of 37 is a little more than 6. Again, you can look at those decimal values if you'd like to, but again, we're just trying to use those approximation values. That way it's a little bit easier. Same idea for the next one. How do we know it's a little less than 10? Well, we can say since the square root of 100 is exactly 10, then we could say the square root of 95, which is a little less than 100, or sorry, the square root of 95 is a little less than the square root of 100, so we're going to say then square root of 95 is a little less than 10. So again, real simple for each of these. Then for that last part, let's do in green. How do we know square root of 30 is between 5 and 6? Well, we said since square root of 25 is equal to 5, and we know that the square root of 36 is equal to 6. That gives us, say then, the square root of 30 is between 5 and 6. So again, make sure you're kind of using those perfect squares. So please, use perfect squares. All right, in the second part, it says plot each number on the number line. So it gives us 5 numbers. Try plotting those out. Again, use calculator to get decimals. I can write that decimals. Another reminder though, if you don't want to try using those decimals, what you can do, I know that this is the square root of 25. This is the square root of 36, square root of 49, square root of 64, square root of 81, and the square root of 100. So a way you can do it is either using the decimal value or using those perfect squares. So your turn. So pause for your turn. Again, and pause and check with me. That way you can make sure your answers are correct. All right, for number 3, it says mark and label the position of 2 square root values that are between, again, that keyword is between, 7 and 8 on the number line. So make sure you're not saying, so you can say, again, square root of 49 is equal to 7, and then on the far end we have square root of 64 is equal to 8. So that means this. We can say, so let me help you out here. I can say choose any square root of numbers from, so if I said the square root of 50, so the square root of 50 to the square root of 63. So remind yourselves, I cannot, if I wanted to place, like if I want to say, hey, I can place, 53 on here, I know that is incorrect because it has to be between 7 and 8, which 53 is not between 7 and 8. However, I could do something like, putting the square root of 53 on here, or the square root of 55. Any of those options will work. So choose a number. So you choose any number or any square root of those numbers. And then it says select all irrational numbers in the list. Again, make sure you're remembering what irrational means. We're saying not rational. So that means values that it does not end, and it does not repeat. It must not do both. If it does one of those, it's going to be rational, and we're looking for ones that are not rational. Also, make sure you're saying if it's not rational, it's not a ratio. So right away, just by looking at that, those first two ones are incorrect because those are fractions. If I look at the third one, square root of 14, so let me pull up that Desmos calculator. I'm going to clear out some of these numbers real quick and pull this back up here. So if I need the square root of 14, square root on 1/4. Notice how there's no real pattern for those values. It's not a perfect square, so then I'm going to say that the square root of 14 is going to be irrational. So let me select that one. So again, I'm looking for irrational numbers. And I'm going to pick square root of 14. Square root of 64, that's equal to 8. So square root of 64 equals 8, so that's not rational. Square root of 9/1 is the same as 3/1 because square root of 9 is 3, square root of 1 is 1, and so that's a fraction, so that's not right. Square root, or the negative square root of 99, let's check that one out. You can use that Desmos calculator for you guys. So let's say can have that negative on the outside. It's a negative square root of 99. No, not repeating, not ending. And so I can say square root of negative square root of 99 is it's irrational. So that's why I selected. And lastly, when you know that the square root of 100 is 10, so negative square root of 100 is equal to negative 10, which is a rational number. So only those two choices are what we're going to pick. For the exit ticket, I'm going to let you try this one out on your own, but it says which of the following numbers are greater than 6. So it has to be greater than 6 and less than 8. So try that one out. Be sure to turn in, so finish both sides and turn in. Make sure you can ask questions at any point in time, and as always, super slam that subscribe button.